ATMs feel outdated. They have small screens, simple menus, slow response times, and interfaces that look like they have not changed in decades. Compared to smartphones and modern apps, they seem frozen in time. This leads many people to assume something must be wrong. Why do ATMs still use such old technology? The short answer is not neglect or incompetence. It is deliberate. To understand why, we need to look at what ATMs are actually designed to do and what they are designed to avoid. ATMs were created to perform a very small number of critical tasks: dispense cash, check balances, accept deposits, transfer funds. They do not exist to be flexible, stylish, or constantly updated. They exist to be reliable, predictable, and secure. Those priorities shape every design decision. Modern consumer technology values speed, visual appeal, and frequent updates. ATM technology values stability above all else. Once a system is proven to work reliably, changing it introduces risk. Banks do not upgrade ATMs the way phone companies upgrade apps. A single failure can affect thousands of users, trigger investigations, or compromise trust. Old technology is not automatically bad technology. In many cases, it is well understood, thoroughly tested, and extremely predictable. Engineers know exactly how it behaves under stress. That predictability is valuable. ATMs also operate in environments that are physically hostile to electronics. They are exposed to heat, cold, dust, moisture, vibration, and constant public interaction. Simple hardware lasts longer under those conditions. Touch screens, advanced processors, and complex operating systems increase points of failure. Every additional feature is another thing that can break. Security is another major factor. ATMs handle sensitive financial data and physical cash. Any change to their software or hardware creates potential vulnerabilities. Older systems may look outdated, but they have been studied extensively by security teams. Their weaknesses are known, monitored, and mitigated. Newer systems introduce unknown risks. Banks prefer known limitations over unknown threats. There is also the issue of certification. ATM software must comply with strict financial and security standards. Updating a system is not as simple as installing new software. It requires testing, certification, and regulatory approval. That process is expensive and slow. Once a system is approved, banks prefer to keep it running as long as possible. Another reason ATMs appear old is compatibility. ATMs must communicate with multiple banking networks, card issuers, and payment processors. These systems were built over decades and must continue working together seamlessly. Changing one part of the system can disrupt the entire network. Backward compatibility is essential. Old technology often persists because newer systems still depend on it. There is also a cost consideration. ATMs are deployed in large numbers. Updating hardware across an entire network requires massive investment. Banks must justify that cost against actual benefits. If a new interface looks better but does not significantly improve security or reliability, it is difficult to justify replacing thousands of machines. From the bank's perspective, an ATM that looks old but works perfectly is doing its job. Another important factor is user behavior. ATMs are used by people of all ages, backgrounds, and technical abilities. Simple interfaces reduce confusion and errors. Complex designs increase mistakes, slow transactions, and frustrate users. What feels outdated to one person feels reassuringly familiar to another. ATMs are designed to be immediately understandable, even to someone who has never used that specific machine before. That limits how much they can change. There is also an operational reason. ATMs must work offline temporarily if network connections fail. They need systems that can recover gracefully without crashing or corrupting data. Older architectures are often better suited for this kind of resilience. Modern consumer systems assume constant connectivity. ATMs cannot. Interestingly, many ATMs do receive updates. They just happen quietly. Security patches, internal improvements, and network upgrades occur behind the scenes. The visible interface changes very little, but the underlying systems evolve slowly. This creates the impression of stagnation when, in reality, controlled updates are happening. ATMs are also designed with longevity in mind. A phone might be replaced every few years. An ATM is expected to operate for a decade or more. Design choices reflect that lifespan. Durable components, conservative software, and minimal interfaces extend usability and reduce maintenance. There is also a legal dimension. Financial systems are subject to audits, investigations, and legal scrutiny. Older systems with well-documented behavior are easier to defend and explain. Newer systems require new documentation, new audits, and new risk assessments. Stability reduces legal exposure. When all these factors combine, the result is a system that changes very slowly by design. ATMs are not behind the times. They are optimized for a different set of priorities. Reliability over speed, predictability over innovation, security over aesthetics. This does not mean ATMs will never change. Contactless withdrawals, mobile integration, and improved accessibility are already being introduced gradually. But these changes are layered carefully on top of existing systems, not rushed. Understanding this makes the design choice make sense. ATMs look old because they are meant to last. They are not built to impress. They are built to work. And that is why ATMs still use old technology.